Dear students, welcome you all to the Industrial Pharmacy class. In this session, we will discuss the general ways of heat transfer, including conduction, convection, and radiation. Remember that the emphasis will be on the general explanation of the different methods, including conduction, convection, and radiation ways of heat transfer, and pharmaceutical applications of heat transfer. Dear students, the main objective is to learn about the various methods of heat transfer, including conduction, convection, and radiation, and pharmaceutical importance of applications of heat transfer. Dear students, the learning outcomes of today's lecture is to learn about the methods of heat transfer, as I already told you: conduction, convection, and radiation, and pharmaceutical applications of heat transfer. After the completion of this lecture, you will be able to learn about these topics. Dear students, as you know, there are three methods of heat transfer, including conduction, convection, and radiation. Dear students, conduction is one of the method of heat transfer which is absorbed and solids which results from the movement of heat energy to the adjacent molecules by vibrational energy transfer and the movement of free electrons. Remember that free electrons is mandatory for this vibrational energy. The molecule either donate or either it will accept heat energy. The molecule vibration depend upon the donation or acceptance of the heat energy. The molecules or electron donating the heat energy will subsequently vibrate to a lesser extent and therefore cool down, whereas the molecule that is receiver or receiving the heat energy will vibrate to a greater extent. That is the extent of vibration. The lesser extent is the donating molecules, and the receiving molecules that receiving the heat energy will vibrate to a greater extent and therefore increase in temperature. The first one will lose heat energy, it will donate and it will become cool down, while the receiver molecule that gaining the heat energy will vibrate to a greater extent and therefore increase in temperature. Remember that no appreciable movement of molecule occurs. We cannot experience by eyes. Heat transfer due to electron movement is generally a greater effect than that due to vibrational of atomic lattice. Therefore, we say that the good conductors and non-conductors and the metallic solids are good conductors because of the free electron, and non-metallics are not because of the existence of few free electrons in the non-metallic solid. And the metallic solids, free electronic is in abundance, and that's why they are good conductors. Dear students, when a fast moving molecule from a region of high energy or temperature collides with slower moving molecules from a region of lower energy, energy transfer takes place. Energy transfer take place will be possible if there is energy difference, and the energy of higher region fast moving molecules will be travel from the higher energy region to the molecules where slower moving molecules are there having a lower energy, and by this movement the collision between the higher energy and lower energy molecules occur, and by this way the energy transfer will take place. Molecules with lower energy gain energy from the high energy molecule due to the collision that I have already told you in the first few lines of this slide, and the higher energy molecule lose energy. As a consequence, the initially high energy molecule temperature will be fallen, and that of the low energy molecule rises due to the transfer of heat energy. Remember that gases become better conductor at higher temperatures owing to faster movement of the molecule, whereas most liquids, with the notable exception of water, become poorer conductors at higher temperature. Dear students, remember that heat transfer by conduction is the main way in which heat is transferred to solids or fluid boundary layers, and is slow compared with heat transfer by convection. On one side, we are transferring the energy by convection process, on the other side on the conduction process, and we are comparing both the rate of heat transfer. The conduction process heat transfer will be slow compared to the convection. The second method of heat transfer is termed as convection. Remember that heat transfer by convection is due to the movement of molecules and their associated heat energy on a macroscopic scale. We can see just like the current. If you experience electric rod you keep in the container containing water, after some time that you will experience the movement of the molecule. It involves the mixing of molecules and occurs within fluid where the molecules are free to move. Heat transfer by natural convection occurs when there is a difference in density within the fluid arising from the greater expansion and hence the lower density of the hotter region. That's why after some time you will experience at the bottom the cold water will be exist, and the water that warm up, and the example of the electric rod and the container if you keep, then you will experience that after the expansion the density will become low and the molecules will travel toward the surface because of the low density of the hotter region. Convection currents are set up as the warm, less dense fluid rises and mixes with colder fluid. As the molecules move, heat transfer between molecules can occur by the process of conduction. Remember that heat transfer by either natural convection, that is due to the density difference, it may be due to the forced convection, which occurs when the fluid is forced to move. We apply external force, either mixture or disruption by the vapors that compel the molecule to move, and by forced convection the rate of the heat energy transfer will be quick. Usually occurs more quickly by forced convection compared to the natural convection. If you are if you are interested in the enhancing the rate of heat transfer, then the forced convection will be possible way to increase the rate of heat transfer compared to the natural convection. That's owing to the greater intensity of the molecule and therefore the increased velocity or movement of the fluid. Remember that the fluid word here used, that is for the liquid and the pharmaceutical. A forced convection also induces turbulent flow. Then the heat transfer process is further added and accelerated, as there will be a reduction in the fluid boundary layer thickness. And the third type of the heat transfer, that is the way of heat transfer, is radiation. The energy emitted by the sun is transmitted in the form of electromagnetic wave to empty space. These waves can be either reflected, transmitted, or maybe possibility of the absorption. When they are absorbed by a body on which they fall, energy reappears as heat and the body increases in temperature. Remember that all hot bodies radiate energy in this way, but heat transfer by radiation is only of practical importance to pharmaceutical processing during drying. Dear students, after the explanation of the different ways of heat transfer, in this part of the lecture we will try to understand about the pharmaceutical applications of heat transfer. There are a number of processes which involve heat transfer and a number of production of the dosage form. One of that is we are going to melt material and we need an elevated temperature using the process of cream production, suppository or ointment production. So heat energy transfer or heat transfer is practically applicable in melting of the material. Similarly, heating of solvent to hasten dissolution processes. If we are going to add preservatives and poorly dissolution has to be overcome by heating of that particular solvents to increase the dissolution of the preservatives and the manufacture of solution products. Similarly, in the sterilization of product, for example, using steam and the autoclave during the media preparation for sterility testing, sterilization of the product, the heat transfer is practical application has a prime importance as well. Evaporation of liquid to concentrate for product. Whenever we require the concentrated product, then the liquid is to be evaporated by the application of heat. Similarly, heating or cooling of air and air conditioning plant and HVAC, that is heating, ventilation and conditioning plants. Sometimes we need heat, sometimes we need cool temperature. So the practical importance of the heat transfer in the process of heating or cooling of air in the air conditioning plant as well. Another application is during the drying of granules for the tablet production. You can consult Order Pharmaceutics, the Science of Dosage Form Design, second edition, for this topic as well. Thank you all for your attention.